Today we'll talk about AI agent loop patterns, not what an agent is in theory and not the full anatomy of an agent. Here we focus on the practical part. How an AI agent runs step by step. Most modern LLM agents follow some version of the same cycle: sense, think, act, observe, repeat, finish. The model reasons about what to do next, calls a tool or produces an action, observes the result, and then decides whether to continue or stop. This is the foundation behind many agent systems: coding agents, research agents, RAG agents, customer support agents, automation agents, and multi-tool AI workflows. In this video, we'll go through the most common ReAct-style loop patterns and when each one makes sense. I'm building this series step by step. If you want to catch the next videos on agents and architectures, subscribe. If this episode clarified the anatomy for you, a like really helps the channel. Table of content. What agent loop patterns are: ReAct, Conversational ReAct, ReAct with description, multi-action ReAct, iterative ReAct, ReAct with reflection, ReAct with memory, ReAct with planning, chain of thought plus ReAct, tree of thought plus ReAct, sandbox execution agent, ReAct with learning, final takeaway. If you want more on agent anatomy, loop patterns, strategies, RAG anatomy and strategies, LLM engines, vector DBS, and MCP, the hub page is linked below. That's the map I use to tie the pieces together. An AI agent is not just a chatbot that returns text. It uses an LLM together with tools. Those tools can be APIs, databases, file systems, search engines, browsers, code execution, or other external systems. The important part is the loop. The model receives input, reasons about the next step, performs an action, observes the result, and then decides what to do next. That cycle is what makes the system feel agentic. A normal chatbot gives one answer. An agent can take multiple steps. It can search, inspect data, call a function, read the output, change direction, retry, ask the user, or stop when the task is done. So when we talk about agent loop patterns, we are talking about different ways to organize that repeated cycle. The basic pattern is ReAct, which means reasoning and acting. The loop is think to act, to observe, to repeat, to result. The model first reasons about what should happen next. Then it acts, usually by calling a tool. Then it observes the result of that tool call. That observation is important because it grounds the next step in real data. For example, if the agent searches a database, the database result becomes the observation. The model then uses that result to decide the next action. The strength of ReAct is that it creates a clear flow. The model is not just guessing from memory. It can interact with the outside world and update its next step based on what actually happened. The downside is cost and latency. Every extra loop means more model calls, more tool calls, and more time. If the prompt is unclear or the tools are badly designed, the agent can also get stuck calling the wrong tools again and again. So ReAct is the simplest useful pattern, but it needs clear tool contracts and good stopping rules. Example: what is the weather in Hoboken today, and should I carry an umbrella? Think: I need current weather data. Act: call weather API. Observe: rain expected at 3 p.m., 12 degrees Celsius. Think: since rain is expected, recommend umbrella. Result: yes, carry an umbrella today. The model did not guess the weather from memory. It used a tool, received real data, then reasoned on top of it. The next pattern is Conversational ReAct, sometimes called ReSpAct. This adds one important ability. The agent can talk to the user during the loop. The loop becomes sense arrow, think arrow, ask or speak arrow, think arrow, act arrow, observe, arrow, repeat arrow, final result. This is useful when the user request is ambiguous. Instead of guessing, the agent can ask a clarification question. For example, which database should I query? Do you want a short answer or a detailed report? Should I apply this change or only show the plan? This pattern improves trust because the user stays involved. It also reduces wrong tool calls because the agent can ask before acting. The trade-off is speed. More conversation means more round trips. That can be good for interactive assistants, but bad for automated workflows where you want the agent to run without interruption. Use this pattern when user confirmation or clarification matters more than raw speed. Example: find the best restaurant for dinner tonight. Input: find the best restaurant for dinner tonight. Think: best is unclear. I need preferences. Ask: what cuisine do you prefer and what city are you in? User: Italian, Hoboken. Think: now I have enough context. Act: search Italian restaurants in Hoboken. Observe: several highly rated options found. Ask: do you want casual dining or something upscale? User: casual. Think: filter based on preference. Final result: I recommend a casual Italian restaurant in Hoboken with strong reviews. Another variation is ReAct with description. The loop: think to, optionally describe what it will do or has done. To act to observe to ... to final result. But the agent also describes what it is doing or what it has done. For example, I'm going to search the documentation. I found 3 relevant files. Now I'll compare the results. This is useful for transparency. Users do not want to watch a black box. If an agent is doing multiple steps, short status updates make the process easier to trust. This is also useful for debugging and audit logs. The risk is noise. If the agent describes too much, the experience becomes slow and annoying. Descriptions can also drift from reality if they are not based on actual observations. So this pattern is best when visibility matters: debugging, compliance, complex workflows, or user-facing automation. Example: fix the bug in my API where login sometimes fails. Think: I need to inspect authentication logic. Act: open login controller file. Description: I'm checking the login handler for potential issues. Observe: found JWT validation, mismatch in token expiration check. Description: I found a possible cause. Token expiry is not being validated correctly. Act: search documentation for JWT expiration handling. Description: comparing correct JWT expiration implementation. Observe: confirmed correct fix approach. Think: apply fix and update validation logic. Act: patch code and rerun tests. Description: I updated the validation logic and reran the tests. Observe: all tests pass. Final result: login issue fixed. Token expiration validation was corrected. In basic ReAct, the agent usually performs one action at a time. In multi-action ReAct, the agent can call multiple tools in one step. The loop becomes think to act. With multiple tool calls, to observe all results, to think again, to ... to final result. For example, the agent might search documentation, query a database, and calculate a value in parallel. This can be much faster than doing everything one by one, but it only works when the actions are independent. If one tool call depends on the result of another, parallel execution can create ordering problems. There is also more risk with side effects. Reading from 3 sources is usually fine. Writing to 3 systems at once is dangerous unless the workflow is very controlled. So multi-action ReAct is useful for independent lookups, parallel search, comparison, and aggregation. But for ordered workflows, keep the steps separate. Example: get the latest stock price of Apple, Microsoft, and Google and compare them. Think: I need stock prices for multiple companies. Act: multi-action. Call API: get stock price AAPL. Call API: get stock price MSFT. Call API, get stock price GOOGL. Observe. AAPL, $190. MSFT, $410. GOOGL, $175. Think. Now compare values and determine highest and lowest. Final result, Microsoft has the highest stock price at $410. Apple is $190. Google is $175. I'm building this series step by step. If you want to catch the next videos on agents and architectures, subscribe. If this episode clarified the anatomy for you, a like really helps the channel. That's it for this first part. We covered what agent loop patterns are, why the loop matters, then ReAct and a concrete weather example, conversational ReAct with Hoboken/restaurant clarifications, ReAct with description on a real API login debug trace, and multi-action ReAct with parallel tool calls, and the AAPL/MSFT/GOOGL comparison. Next, in part 2, we'll go through the rest of the list: iterative loops, reflection, memory, planning, and stronger reasoning, chain, and tree of thought. Part 3 will cover the sandbox pattern, learning from feedback, and a short wrap-up on trade-offs in picking the right loop. If this helped, use the same playlist so you don't miss the follow-ups.